This is meant as a quick demonstration of the capabilities in R for implementing spatial data animations. I have on my blog various documentations on relevant packages, and if you're interested, you can see the video description and click some of the links taking you to coding examples that get you started with creating an animation like this. So in spatial data visualization, as I see it, there are always the same steps when you want to visualize something, as you can see here on this map. First, you of course need to obtain the data. You need to clean and manipulate the data. You could, for example, use something like dplyr for that. Also depends on where you get your data from, so you need to be able to read in the data um, from the relevant source. In this case, it was data from SPSS, so I was using the Haven package, allowing me to read in SAP files. Um, and then once you got the data and you clean the data, then usually, the, in many cases, the data does not contain the geo coordinates. So your data will not contain the latitude, longitude information, which means that you don't have information on where on the map uh, this data point is located. So you will need geocoding. So you need to execute geocoding, and once you executed the geocoding step, you have added the latitude and longitude information to your data set. And then you can visualize the data. And there are many packages that allow you to visualize data in R. I've covered many packages on my blog. You can for example visualize data with ggplot2 or ggmap, which is based on the same grammatics. In this case, I use ggmap, but you can also use something like leaflet or deckgl, just to mention some of the examples that are also covered and documented on my blog. And if you're interested in that, you can also see the video descriptions and get some links to some coding examples with those packages and see some of those visualizations. But the reason why I use ggmap for this example was that it fits nicely with the gganimate package in R. And gganimate was originally made to enable ggplot2 based animations. So it's based on the same, let's say, framework, or it builds on the framework that ggplot2 is built up around, and allows you to develop animations quite simple, at relatively low effort. And since ggmap uses the same framework, the same grammatics as ggplot, it fits directly with gganimate. So together, gganimate and ggmap allow you to create spatial data visualizations and animations, such as the one that you can see here. And what you see here are so various groups, specimen groups, and throughout time, you can see here the year being incremented. These specimens were detected throughout the world, and what I'm trying to show here is how the specimen spread throughout the world throughout time, based on this data set that contained basically the detection location of the specimen, so new detection locations. So I'm aggregating the detections throughout time, and I'm showing and animating here how the spread developed throughout time. The bounding box in this case contains more or less the world. You can, for example, get the bounding box from OpenStreetMap. There's another example here with the same animation where I adjusted the bounding box to only include Europe. This is something you can directly specify in ggmap. So go ahead and see the ggmap documentation on my blog to be able to understand how to adjust the bounding box for ggmap plots like this one. And then I also did some other things that were not animation based. For example, I combined two pieces of information. So using kernel density plots that you can also create with ggmap, since it's ggplot2 based, and kernel density plots are part of ggplot2. Using those kernel plots, I showed how basically the density of already detected specimens for a defined group, how that density was distributed spatially. And with scatter plot points, I showed for the given year and the given group where new detections were registered. So this combines two pieces of information. In this year, how much spread has already taken place for the specimen group, and for this given year, where were the new detections? So we can see there's already been a lot of spread going on in Western and Northern Europe, and in this year there were some new detections far away in in the more of the east, and actually here already in Asia. And to summarize this overview, in this case, I built a framework around various packages. So I used Haven to read in data from SPSS, dplyr for manipulating and cleaning the data, rearranging it. And then I used ggplot2 and magrittr, as well as ggmap for like building plotting workflows. And for the animations themselves, I needed to use a transformer, gifski, and ggganimate, which then allowed me to, for example, create the GIF animations. So those were the packages that I used. And if you want some more documentation on the various packages, you can find that on my blog, and you can see in the video description. This was just meant as some inspiration to show you what kind of visualization you can achieve with very simple uh, work or pipelines, and very compact and easy to understand R code using RStudio, and basically mostly the packages ggmap and gganimate.